Hello, students. I'm going to teach you for this textbook, Gr.12 Advanced Function, Hill Ryerson. I'm going to teach you for Chapter 2 test today. I will use the simplified way to explain to you to help you understand easily. Please subscribe my video. Thank you. Let's start. Chapter 2 practice test. So number 1, which statement is true? So for the function, p and x equal 5x exponent 3, f4x exponent 2 minus 3x plus 2. So we have 4 options. The first one, when p and x is divided by x at 2, the remainder is the a. Then you check. So if x equal -1, this will be -5. At +4, you get -1. And at 3, you get +2. So +2, -2 has no remainder, so not A. How about B? X plus 2 is a factor, so we put -2 here. So we have a -5, -8 times 5, we get -40. -40 at 16, so will be +56. It's not the factor, definitely has a remainder. So how about C? P equal -2 at -2, so you're going to get a -16. If this is correct, let me write down on paper to explain to you. Now when x at 2 is the factor, we plug in the x value equal -2. So 5 times -2 exponent 3. So equal 5 times -a, we get -40. Now 2 is 4, 4, 16. So it's +6. That's at 2. So what are we going to get? This is 22, 24. 24 positive subtract from -40. You're going to get -16. Yes, this is the answer. So therefore, we must C is the answer for question 1. Now, how about question 2? So I'm going to read it for you. So question 2, which of the following is not the factor for the function 2x exponent 3 minus 5x exponent 2 minus 9x at 18. So the first one given to you is A. So we have a 2x minus 3. So, and then B, we have an x at 2. And then C, we have an x minus 2. And then D, we have an x minus 3. So which one are the two? So we go to substitution. If we plug in the x value into the function, it has no remainder. This will be true. So now we find the first one. So x is equal 1.5. So you can directly plug in. So 2, we're going to write when x is equal 1.5 for the first one. So we get 2 times 1.5 exponent 3 minus 5 times 1.5 exponent 2 minus 9 times 1.5 at 18. Now that's for the A. Now for the B, we're going to put for F at -2. So equal to times -2 exponent 3. So minus 5 times -2 exponent 2 minus 9 times negative 2, 18. So, and then C. C is when F at the 2. So we're going to write 2 exponent 3, 5, 2 square, minus 9 times 2, 18. So we are going to use a calculator to plug in to try. Let me try from the back to the front. So let me try 2 here first. So that's the 8 times 2, 16. So that's the 4, 5 times is 20. So minus 18, add 18. So, and from here, we are going to find the answer. And from here, we're going to find the answer. The answer is negative 4. So therefore, this one for this the answer. Good. 2 is C again. Now we are going to look at the question 3. Now question 3. So which one is the possible x-intercept for 4x exponent 3 minus 5x exponent 2 minus 23x minus 6? So the formula to find the x-intercept. So this is called B and that's called A. So it will be B over A. Now, what's the factor for B? Will be positive and negative 1, positive and negative 2, and positive and negative 3. So how about A? A is going to be positive and negative 1, positive and negative 2, positive and negative 4. So now we are going to test. See which set is the factor. Now we are going to write down all the factors here. Now if A is a 1, so we're going to have a 1 divided by 1. So we're going to have the first factor. So 1, 2 over 1, and 3 over 1, and 6 over 1. So from here will be all of them are positive and negative. We write the integer. Now, and then we are going to do 2. So 2 to 2 is a 1, and 2 to 4 is 1 over 2. So each one is going to be divide the factor. So for 2, we are going to have a 2 to 1, we done already. 2 to 2. So 2 to 2 is a 1. So positive and negative 1, we done here already. So, and then 2 to 4. Positive and negative 2 to 4 means 1 over 2. Now we do 3. So 3 to 2. And 3 to 4. So, and then we do 6. 6 to 1 we done. How about 6 to 2? So will be positive and negative 3. And 6 to 4 will be positive and negative 3 over 2. So if you find all these factors, you're going to find they match. So 3 and 3 here overlap. We only take 1, so we don't need this one. So if you look at the book for ABC, only D qualify. So D. So D will be the answer, positive, negative 1, 2, 3, 4, 6, 1 over 2, 3 over 2, 4 over 3, and 3 over 2. That's the answer for question 3. Let's move on for question 4. Now for question 4, we are going to write it in a quotient form. Like x exponent 3 minus 4, x exponent 2 plus 3, x minus 7. The factor x f3, write it into a fraction. It's called quotient form. Now we're going to do a long division to find the answer. So the long division, the first leading, you have to cancel it first. So therefore, we put x exponent 2. So multiply x exponent 2 times x, we get x exponent 3. So, and times 3, 3x exponent 2. So when we subtract it, we cancel the first leading. This become negative, positive, we got negative. We add it together. Negative 7x exponent 2. Bring the next term down here. We try negative 7x. When you multiply, we got negative 7x exponent 2 minus 21x. So we are going to subtract it and change the integer. Cancel the first one. And we got 25x minus 7. So we're going to add 25 here. So excuse me. So here should be 24. Why? Because 21 add 3, we get 24. It's then 25. So I change it. So and then if this 24 and 24 times 3, I got 72. Negative, positive, I got negative. So and their add will become negative 79 is the remainder. So now we are going to complete the division statement here. So this divide, you got the answer x exponent 2 minus 7x at 24. The remainder is minus 79 over the x factor. So we complete the division statement in A. Now for B, can you write any restriction? Yes, we solve this x-intercept. So x is not equal negative 3. That's for a B. Now how about for a C? So we're going to find. So for C part, you're going to find the correspondence statement. You can check the answer. So you can write the answer here. For x, x3 is the factor times the answer. X exponent 2 minus 7x at 24 minus 79. So from this answer, you can verify. So how are you going to do it? You're going to do distribution and then add the remainder. It will come back into the original function. So let's do that. So we're going to multiply x times x. We have x exponent 3 minus 7x exponent 2. So and then add 24x. Add 3x exponent 2. And then 3 times 7 minus 21x. 3 times 24. So 3 times 24, what are we going to get? You can do mental calculation. 3, 4 is 12. And 3, 2, 6 is 72. Minus 79, the remainder. I barely have enough room here. Now we simplify. So it's equal x exponent 3. So these two you combine, you are like term. You have a 4x exponent 2. And these two are like term, you combine. You have a 3x. And these constant number you combine, you get negative 7. So after you verify, you got back into the original function. It means it's 100% correct. We done question 4. Let's do question 5. Question 5. f and x is equal x exponent 4, 8k x exponent 3 minus 2x exponent 2 at 1. And this question is for the factor x at 2 to prove if the remainder is a 5. So and from here, we also need to find the value for k. That's the purpose. Now we're going to do plug in. So f at a negative 2. So we put here, we have a negative 2 exponent 4 8k times negative 2 exponent 3 minus 2 times negative 2 exponent 2 at 1. The remainder is 5. So now from here, we get 16. At negative 8k. And that's the 4. 4 times 2, we got negative 8. At 1 equal 5. Now we have only one variable. We're going to solve this equation. We put negative 8k is equal 5. So 16 minus a, we get a. A at 1, we get 9. So equal negative 9. Now k is equal negative 4 over negative 8. And then k equal 1 over 2. So we solve for a. So k equal 1 over 2. Now we're going to solve for b. So b is asking. So find the remainder when the factor is x at 4. So r equal how much? So we're going to do plug in here. So I'm going to move on here. So we put negative 4 exponent 4 is 8. So we know k is 1 over 2. So 1 over 2 times negative 4 exponent 3 minus 2 times negative 4 exponent 2 at 1. So 4 exponent 4, what are we going to get? I'm going to use the calculator. So 256. And then you're going to plus, and this will be a minus because this is a negative exponent 3. So 4 exponent 3 is 64. So 64 divided by 2, we got 32. So therefore minus 32. And then this is 16. 16 times 2, negative 32. And add 1. So what is the remainder? So we put 256 minus 32. 32 is 64 and add 1. So the remainder is 193 for question 5b. So, and this is the remainder answer for B. And question C asking you use a long division to verify if this remainder is correct. So we're going to do a long division here. So we have an x exponent 4 at 1 over 2 x exponent 3 minus 2x exponent 2 at 1. So the factor is x at 4. So the first one we try is x exponent 3. So we get x exponent 4 at 4x exponent 3. So we subtract it. We cancel it. So this is a negative. Negative 4 minus 0.5. We have negative 3.5. X exponent 3. So bring the 2x squared down. So it will be minus 3.5x exponent 2. So we have a minus 3.5x exponent 3 and going to be a minus. So 3.5 is 14. So minus 14x exponent 2. So we subtract it. So that's going to be 8. We have a 12. I'm running out of room. 12x exponent 2. So you know exponent 2 here, we need the x here. We actually need to insert here. Plus 0x to take the position. So we're going to put here, it will be 8, 0x exponent 1. So I'm going to use a second page and continue it. Good. Let's roll. So from here, we're going to try 8, 12x. Then we have a 12x exponent 2. 8. 4 times 12 is going to be 48x. So we subtract. So negative. This will be a negative 48x at 1. So here, so we are going to put is minus 48. So we got minus 48x and then minus 48 times 8. 48 times 4, excuse me. I got 192. So we subtract it. When we subtract, we change the integer. We got 193. So therefore, we verify the remainder is 193, same as the part B. And that's all the long calculation for question 5. Well done. We are going to move on for question 6. So this is question 6. So factor the equation. We have an x exponent 3 minus 5x at 2x minus 8. So we're going to try a factor for a negative 1. So if negative, I got negative 1 here and negative 5 here is negative 6. Negative 2 here, negative a. Negative a, positive a. We got it correct. So we're going to write the factor is x at 1. So we're going to divide and find the equation. So we put a synthetic division here. So it's more simpler than long division. So we write all the coefficients. 1, negative 5, 2, and an a. So this is the x plus 1. So when x plus 1, we're going to subtract it and x value will be here. The first one we move down is a copy. 1 times 1 is a 1. This will be negative 6. So will be negative 6 here. So will be an a. So will be a positive a, will be a 0 here. So we're going to write the factor. The next part we got is x exponent 2 minus 6x at 8. Now it's much more simpler. So we have a 2 times 4 is the a, and 2 at 4 you get 6. So therefore the answer is x at 1 and x minus 4 times x minus 2. And here the answer for a. So now we are going to do question 6b. So for question B, x exponent 3 at 2x exponent 2 minus 9x minus 18. So for the A, the factor only 1. And then for B, we have a positive, negative 1, and 2, and 3, and 6, and 9, and 18. So let's try a smaller number. I know 1 is not work. Like 1, positive 1, and negative 1 not work. So, and then how about 2? So it's 2 work. So let's try positive 2 not work. Let's try negative 2. So if negative 2, we're going to have a negative a here. And we are going to have a positive 4 here. So we have a negative 4. And we are going to have a positive 18. It cancels, it's not work. So how about 3? Negative 3 work. So we have a negative 27. And 9 times 2, it's going to be 18. Negative 27 minus 18. Okay, I'm going to use the calculator to help faster. So if we try a negative 3, so we get negative 27 here. The second one will be a 9. 9 times 2 is 18. So add 18. So and then 9 times negative 3, we get positive 27. So and then add 27 and minus 18. Yeah, it's equal 0. So by the calculator, we find this equals 0. Then we're going to put x at 3. So from here, we're going to do a synthetic division. So x at 3. So we write all the coefficient here. So the first one is a 1, is a 2, is negative 9 and negative 18. So we're going to subtract it. We bring the 1 down. We got 3 times 1 is a 3. We got negative 1. 3 times negative 1, negative 3. So, and we're going to get negative a here. Excuse me. So negative, negative, we get a positive. Negative 9, positive 3, we got the negative 6 here. And positive 3, negative 6, we get negative 18. So there's no remainder. So we're going to find it's going to be x exponent 3 minus x exponent 2 minus 6. So from here, we can continue factor. 2 times 3 is 6. And 3 minus 2, you get 1. So we have an x at 3 times x minus 3 and x plus 2 is fully factoring. We are going to do C. So for C, we have x exponent 3 at 5, x exponent 2 minus 2x minus 24. So we're going to, this is the positive and negative 1 for A, and B, we have a positive negative 1, 2, 3, 4, 6, 12, and 24. So we're going to try a smaller number. Let's try 1. So 1 is not work. So 1, 5 is only 6. Yeah, it's not work. So we're going to try larger number. So how about try 2? So 2 might work. So we're going to use the calculator. So 2, if it's a negative 2, we're going to have a negative a in front. The next one is going to be 5 times 4 is 20. So, and 2, negative is 4. So, and then minus 24. It's got negative a. It's, how about positive? So we try positive. 27. So, and then add 18. So, and then minus 4. And then minus 24. It's equal 17. So let me see. We're going to try another number. Minus 2 work. So we're going to put 2 here. We have a positive a. So we're going to write a synthetic division here. So x minus 2. So it's subtract. We have a 1, we have a 5, we have negative 2, we have 24. So we bring the 1, 2 down here, excuse me, negative 2 times 1, we got negative 2, we got 7 here. And negative 14, we get positive 12. We get negative 20, negative 12 and times 12, we're going to get 24. So we got a negative 24 here. There's no remainder. So we move this one here. It's going to be equal x exponent 2 is 7x is 12. So 3 times 4 is 12. And 3 is 4, you get 7. So we got the factor here. So x at 3 and x at 4. We fully factor question 6C. Now the next one will be D. So 6D. 5x exponent 3 is 7x exponent 2 minus 8x minus 4. So we're going to try all the factors. For 5, you're going to have a positive and negative 1, positive and negative 5. For 4, we have positive and negative 1, 2, and 4. So let's try 1 first. So if it's a 1, so we're going to put it x minus 1. So 1 at 5 at 7 is 12. So negative 4 is 12 too. Perfect. It works. So we're going to put a synthetic division here. So we have an x minus 1. So we have a 5, we have a 7, and negative a, and negative 4. So we subtract it. So we bring the 5 down. 5 times negative 1, we get negative 5. So we add will be 12. So, and then negative 12. We subtract. We're going to have a positive 4. And we have a negative 4. No remainder. So we're going to put it here. We have a 5x exponent 2 at 12x at 4. So from here, we're going to find a factor. So let's say 5x. The combination will be 5x times x. How about 4? We have a 2 and a 2. 2 times 2 is 4 or 4 times 1. Let's find this one. It works. 5 times 2 is a 10. 10 and 2 is 12. We got it fully factor. So we put 5x here. And we put x here, we want a 10. So put 2 here, put 2 here. That's the fully factoring. Now we are going to do the next one. So for E, x exponent 3, x7, x exponent 2 plus 26x at 24. So again, the leading here for A is positive and negative 1. And for 24, we have a positive and negative 1, 2, 3, 4, 6, 12, and 24. So we're going to try a smaller number. So if one works, they are positive, not work. How about negative? So negative and negative, we got negative 27. So 27, 24, and 9, you get 33. It's not work. Now we try a 2. So positive definitely not work. They are positive. Negative 2 work. Negative 2 work. So we put x plus 2. So now we are going to put a synthetic division here. So x at 2. So we have 1, 9, 26, and 24. So we're going to subtract it, bring the 1 down. So we're going to have a 2. So 2 is going to be a 7. So, and then will be a 14. So subtract, we're going to have a 12. 12 times 2, we get 24. So we write it here. Will be x exponent 2 at 7x at 12. So 3 times 4 is 12. 3 and 4, you get 7. So x at 2 times x plus 3 and x plus 4 is fully factoring for 6E. The next question. So for question 6F, 2x exponent 4 at 13x exponent 3 at 20x exponent 2 at 23x is 6. So the factor here, the leading, is positive and negative 1 and 2. And the B is positive and negative 1, 2, 3, 6. So we're going to try a smaller number. So definitely not for positive. You see, positive 1, it won't work. How about negative? Yeah, negative will work. So we're going to put X at 1 as a factor. So we do synthetic factor here. So X at 1 is a minus. We have a 2, 13, 28, and 23, and a 6. So we bring the 2 down. So 1 times 2 is a 2. So we got 11. So 1 times 11, we get 11. We're going to get 17. So, and then 1 times 17 is 17. And 23 minus 17, we got 6. And we got 6 here. So now we do the first factoring here. So we're going to have x, 2x exponent 3, and 11x exponent 2, and 17x is 6. So from here, we are going to try another factor. Excuse me, my phone rang. So from the Q-bar function here, they're all positive. So we can try the factor for a positive. We only try negative will work. So negative 1 work. So will be negative 2, positive 11, negative 17. So negative 19 and 11 and 6 is not work. And it must be a negative 2 will work. So we put x at 1 times x at 2. So we're going to synthetic this Q-bar function here. So x at 2, we minus it. So we're going to put 2, 11, 17, and 6. Now we bring the 2 down. So 2 times 2 is a 4. So 11 minus 4, you got 7. Excuse me. Yeah. So, and then we are going to put 2 times 7, we got 14. So you subtract is a 3. 2 times 3 is a 6. So the next part we got here is 2x exponent 2, 7x x 3. So is this part is going to be factorable? We're going to try. So we have a 2x combination and an x, and it's 3 and a 1. So 2 times 3 is a 6, 6, 1 is 7. Yes, we got it. So we're going to write the final answer here. I'm going to move a little bit more in here. So x at 1, x at 2, and 2x and an x. We want a 6. X3 at 1. So now it's fully factoring for question 6F. A quadratic function factor to be a Q-bar to be a quadratic. Wow, lots of work, but we done it. We did it correctly. Now we're going to move on for the next one. So question 7 is read the graph to find the root in the interval from negative a to a positive a, and y is negative 14 to positive 14. So by reading the graph in the book, we approximate find that x is about negative 7, negative 2, and a 3. So that will be the answer. Let's do question 8. Now, question A is find real root. So you have the A. So from here, you can tell x squared equal negative 5 has no real root. So the real root x equal 2. So we find the first one. The second one, this is no real root. This one will be 11. So x You can write like that. X equal 121 equal 11. So here we're going to find 1 here. So if X will be 15 divided by 2, you get 25. So you're going to put X is equal 15 divided by 2 square root equal 5. So how about this one? You can factor it. So 3 times 1, negative 3. Negative 3 times positive 1. You get 3. And the C part for here looks factorable, but it isn't because it's the positive 3. So it's not work. So only factor this part. Now, how about here? So this is factorable. So we're going to have 27 divided by 3, you get 9. So it's the 3, it's a 2, it's a 2. So we're going to find the answer here. X exponent 2, F3x at 2. We continue factor. X at 1, X at 2, and X at 1. So we fully factor it. Let's do B. Now B is X exponent 3 minus 13x at 12. So how about we try the factor for a 1? Oh, 1 works because positive 1 at 12 is 13. So we're going to put X minus 1. So we do a synthetic division here. So X minus 1. So we're going to minus it. We have a 1. We have a 0. We have a 15. We have a 12. So we put the 1 here. So negative 1, we have a 1. And negative 1 here. So we're going to get it for 12. And 12 divide it. So from here, we are going to get negative 12. We get positive 12. So we write it like the answer will be X exponent 2 at X and minus 12. And we continue factor. X minus 1. So X at 4. And times X minus 3. So it's fully factored. So for C is a very huge number to look for a factor. So let's find all the factor for 32 and 47. So I'm going to write here. And this is the B and that's the A. So we have a B over A. Now B has positive and negative 1. Positive and negative 7. And positive and negative 147. So, and for A, we got positive and negative 1, 2, and 3 not work, 4, 6, and let's do up to here, just some more. So might be work already. So we're going to put 1. So if 1 work, 1 is not work. Because 48 and 98, you're going to get 130, 156 is too small. And negative 1, that's negative 1 work. So negative 1 looks like, no, not work. So we can try, after 1, we're going to try 7. So 7, we're going to have a 2. Okay, let's try 7 over 4 if it works. So you use a calculator. So 7 over 4, we got 32. So 7 divided by 4 exponent 3. So we key in. So and then minus 48 times bracket 7 over 4. So and then minus 98 times 7 over 4. And the last part is 8, 147. Hope it works. It's not work. It's 63. So C 7 over 4. 7 over 4 exponent 3 minus 48 times 7 over 4. Oh, I forgot the exponent 2 here. So we're going to do 32 times 7 over 4. Okay, exponent 3. So minus 48 times 7 over 4 exponent 2. And minus 98 times 7 over 4 and 8, 147 is equal 0. It works. So if 7 over 4 works, we're going to write down the factor. The factor will be 4x minus 7. It's 7 over 4. Now we're going to do a synthetic division here. So we just put 7 over 4. We're going to do an 8 here, if 7 over 4. So we write 32, negative 48, negative 98, and 147. So we bring 32 here. So for 32 divide, I got the 8. So 8 times 7 is 56. So I put 56 here. So again, it's going to be 8. It will be a subtract. So 56 minus 48, I'm going to get the 8, positive 8. Now, and 4 and 8 divide is a 2. 2 times 7, I got 14 here. So, and then 98 minus 14, I got 4 here, I got 8 here, I got 84. So 84 divide 4, I'm going to get 21. Now 21 times 7, I got 147. So from here, I'm going to write the answer. 32x exponent 2, 8, ax, 884. So from the question here, you know this part is factorable. We can factor 4. So we're going to put 4x minus 7. So if divide by 4, I'm going to have an ax exponent 2, add 2x, add 21, and times 4. So from here, a and 21. So I'm going to factor it. Like a, I'm going to have 4x and 2x and 21. I have a 7 and a 3. So am I going to get a 2? And then I try. So 4 times 7 is, okay, 2 times 7 is 14. And 4 times 3 is 12. 14 minus 12, I got 2. Yes, I can get it factoring. So 4x minus 7. And here I got 4x. I move the paper like that. I have a 2x. So I want to get a 12. So 4 times 3. So I put x3 here. And then I'm going to put it, okay, 1 minute. Let me minus 7 here, not 8. Excuse me. It's a minus 7. Now it's fully factor. And the a number here, I have a constant. So the question is factor, 2, 3, x intercept. Very good. We are going to do the next one.